Hi everyone, today's lesson is an Algebra 2 Trig Advanced review for intro questions for your final exam. So let's get started. Some big topics that we're going to be covering in this video and the second video, which will cover the packet that you were passed out to in class for review, are going to be covering trig inverses, trig equations, identities, conics, permutations, combinations, and statistics. So just to get started, one thing that's really important that I wanted to cover is that graphs of inverse trigonometric functions and the limitations and the restrictions that they have. So remember, an inverse trig function stems from, let's say I have a graph. Let's start with a sine graph. Let's say here's my sine. Okay, so let's start with a sine wave that is realistic. So we'll go up, down, like that. And if I were to draw my y equals x axis like this, okay, and I were to reflect my equation, my graph across this axis, this blue part comes down like that, you would get something that would look like this, okay? But because that inverse sine is only going to go from a domain of -1 to 1, but a range of -pi/2 to pi/2. So meaning from this part right here to this part right here. So for arc sine, you have a restriction for your range from -pi/2, pi/2, just right there. For cosine, if I were to draw my cosine wave, starts high, goes down like that, but here also goes down like this. And I were to draw my y equals x axis, and I were to reflect my graph across this y equals x axis, I would get a graph that looks like this and stops at pi, and it starts at here, which is 0. So 0 to pi. Very important. Sine, -pi/2 to pi/2, including those values. Range for arc cosine 0 to pi. And for arc tangent, again, tangent, which looks like this, okay, normal graph like that. If I were to reflect across my y equals x axis, that's what I get. I get this arc that switches over like this to the right and comes like this to the left. But that actually does go on forever for my domain. For my range, just keep in mind that that's a pi/2 to -pi/2, very similar to the sine, arc sine. However, the difference between these two is that for tangent, you're never going to be at pi/2 and you're never going to be at -pi/2, whereas for sine, see the brackets right here? Those are inclusive, whereas for arc tangent, they're not. So just to practice, this is arc cosine. So remember, for arc sine goes from here to here. That's my domain or my range restriction. For arc cosine, cosine's going to go from here to here. And for tangent, tangent's going to go from here to here, but not including pi/2 and -pi/2. So the first question says, where is cosine? That means where are you? Where is cosine -pi or -√2/2? So if you are in these two quadrants only, because those are my restrictions, and I'm trying to find -√2/2, remember that everything in the first quadrant, all students take calculus, all are positive in the first quadrant, but in the second quadrant, sine is positive, which means cosine is negative. So therefore, right here is what I'm looking at. And remember, cosine, this stems from -1 over √2, or excuse me, -1, hold on. This stems from, because it's a √2/2, this stems from a 45-degree angle where it's -1, 1, square root of 2. And so because it's adjacent over hypotenuse, this right here came from -1 over the square root of 2. And so where are you? The question is, where are you? Well, you're at a 45-degree reference, but you can't say 45 degrees because 45 degrees would put you in the first quadrant, which you are clearly not because of this negative sign. So therefore, remember, 45-degree reference is a pi/4, but we're from here to here. So that's going to be 3 pi/4. And again, if you wanted to put that in degrees, you would put that at 135 degrees. For the second question, this says, what is sine of 2 pi over 3? So sine of 2 pi over 3 is over here. It's remember, this is a third less than a whole. So this being pi here, this is a third. If this is 2/3 pi from here to here, this is 1/3 short. 3 goes into 180 60 times, so that leaves me with a reference angle of 60. Across from this 60 degree, you're going to have your root 3. Here's your 2, and here's your -1. So sine of 2 pi over 3 is going to be root 3 over 2. So this value right here is root 3 over 2. But then it's saying, well, where is sine? Where is sine root 3 over 2? But remember, arc sine has a restriction, and remember, it could only go from pi over 2 to negative pi over 2. So where is sine positive root 3 over 2? Well, it can't be down here because that's going to be negative, because in the fourth quadrant, only cosine is positive. But for sine here, we're up here at root 3 over 2. Remember, opposite over hypotenuse. This gives me my 60-degree angle, which is 60 goes into 180 3 times. So this is going to be up from here to here is pi over 3. All right. This question here is saying, where is sine with my restrictions 3 over 4? So remember, sine can only be from here to here. Because it's a positive 3/4, it's going to be in the first quadrant. Remember, sine is opposite over hypotenuse. So therefore, I need this side right here because this is now asking me, what is tangent? Tangent's opposite over adjacent. So far we know that it's 3 over something. So to find this bottom value, we're going to go that value, x squared plus 3 squared is equal to 4 squared. So x squared equals 16 minus 9. So x is equal to the square root of 7. So this will be square root of 7. So then we're going to fix that, and we're going to make that 3 root 7 over 7. This equation, we're going to solve it for the interval from 0 to 2 pi, not including 2 pi with see the parentheses. I do notice this is quadratic. So this being quadratic, we're going to have 2 cosine squared of x, move this over, plus cosine of x, move that over, minus 1 is equal to 0. Quadratic, I'm going to try to factor that, and I'm going to get 2 cosine of x times cosine of x, which gives me 2 cosine squared. 1 times 1 gives me 1. But now I need to figure out what's going to multiply to be -1, but add up to be cosine. So this is going to be negative here, positive here. Because when I check, 2 times 1 is 2, minus 1 is 1, and that's going to mean my positive 1. So that being said, now we're going to split this up into 2 parts. And this is going to go like this, and both sides are going to set equal to 0. So we have cosine of x plus 1 equals 0, and we have 2 cosine of x minus 1 is equal to 0. Cosine of x is equal to -1. Moving the cosine to the other side, x equals arc cosine of -1. And this one, let's simplify that. We get 2 cosine of x equals 1. Now I need to solve. Divide by 2. Cosine of x equals 1/2. And then x equals arc cosine of 1/2. So my 2 parts here is where is cosine -1 and where is cosine 1/2. Now there are no restrictions on this because I'm going from 0 to 2 pi. So where like an inverse restriction would be from 0 to pi is cosine, that's not the case for these values. So for this right here, I can ask where's cosine -1? Anywhere from 0 to 2 pi. So I like to do this a couple of different ways. The first thing I like to do is to show you my cosine graph. So remember, cosine starts high and ends high. So this, to me, is the easiest way to see where is cosine -1. Well, here's -1. Cosine is -1 right here. So you should ask yourself, where are you? If this is 2 pi here, that makes this pi. So this value right here for x, cosine is -1 at pi. The other way that I like to do this is to show a unit circle and say, okay, well, this is 1, 0. This point here is 0, 1. This point here is -1, 0. And this point down here is 0, -1. And so what we're asking is, where is cosine negative 1? Well, if you think about it, all these values are cosine of x, sine of x. It goes cosine first, then sine. So what I'm asking is, where is cosine negative 1? Well, it's negative 1 right here. And where are you? You're from here to here, you're at pi. So again, we have x equals pi. For this one, though, it's a little bit different because this one is saying, where is cosine 1/2? Now, if I go through my all students take calculus, everything's positive here. Sine is positive, which means cosine's negative, so that's out. Here, tangent's positive, which means cosine's negative. Tangent's out. So that means in the first and fourth quadrant, I'm going to get cosine is 1/2. So what I'm going to do is say, okay, well, cosine is adjacent over hypotenuse, which would make this my root 3, and across from root 3 is 60 degrees. So this is going to be pi over 3 from here to here. So we're at pi over 3. And then I know a lot of people, because I know my angle is going to be down here, but a lot of people will want to go from here to here. And I want to make sure that you understand that you can't drop down like that, because that would be negative pi over 3. And remember your restrictions. Negative pi over 3 is not in this area. It's not in that your range. So what you have to do is not do that. You need to start here and go all the way around. So this is from here to here is 1 pi, and from here to here is 2/3 pi. So what's 1 plus 2/3 pi? That's 3, 4, 5/3 pi. So my last value is 5 pi over 3. So my values for this equation right here, to solve this equation, are these three values. The second equation says another quadratic, so I am going to set this equal to 0 again. So we have 2 cosine squared of x, tangent of x, minus tangent of x is equal to 0. Now, normally, if something's quadratic, after you set it equal to 0, you try to factor. But because this is not a trinomial, as in the previous equation, we had 3 terms. But in this equation, we only have 2, which means that I'm going to just simply take out one thing that's common between these two, and that would be tangent of x. So I have 2 cosine squared of x minus 1 is equal to 0. And again, my range goes from 0 to, I have a restricted domain here, so you can only go from 0 to 2 pi. So I'm going to split both these up. I get tangent of x is equal to 0, and I get 2 cosine squared of x minus 1 equals 0. For this left side, I'm going to get x equals arctangent of 0. For this one, I get 2 cosine squared of x equals 1. Cosine squared of x equals 1/2. And then we're going to move this. Okay, so before I move my cosine over, I notice that I have a square here, which means that I do need to square root both sides to get rid of this square. So I have cosine of x equals plus or minus this value here, which remember, this is the square root of 1 over the square root of 2, which is 1 over root 2. And of course, you're not going to leave the root on the denominator. So what I end up getting is root 2 over 2. Moving this over to the other side, I get x equals arc cosine of plus root 2 over 2, and I get x equals arc cosine of negative root 2 over 2. Okay, so I do have all three of these values is what I need to look for to solve this equation. So for tangent, let's just start with tangent. If you think about a tangent graph, tangent goes up like this and then comes down like this. The period is pi, and so dropping this down, this is pi over 2, this is negative pi over 2. And from 0 to 2 pi, so they're asking me to go from here to here, which is 2 pi. So when thinking about that, let me get rid of that. In thinking about that, if I were to add another pi here, right, okay, where is it going to be 0 again? That's what I want to know. So if my period is pi, my next value where tangent's going to be 0 is pi plus pi over 2. So 2 over 2, which is 3 pi over 2. So far for tangent, I've got 0. I've got 3 pi over 2. Remember, this is not 0 degrees because I'm writing my equations in radians. So let's see, what do we have next? Okay, those are those two. The next one are these two here. So where is cosine root 2 over 2? So we know that that's going to be a 45-degree reference. And for me to have 45 degrees for cosine 1 square root of 2, right, this is going to be in every quadrant, because in this quadrant and this quadrant, first and fourth, I'm going to get cosine to be positive. But in these two quadrants, cosine is going to be negative. So my values are going to be pi over 4, then from here to here, which is 3 pi over 4, okay? And then we have 1 and a fourth, so 1 and 1/4 is 5 pi over 4. And then we have 1 and 3/4. 1 and 3/4 is going to be 7/4. So all of these values, so let me erase this little a here so I can add one more value here. Okay, so 5 pi over 4 and then 7 pi over 4. And so all of these values are solutions to this equation. The next question says, find the vertex of the parabola. So a couple of things to remember with parabolas. You have either an equation that looks like this, y equals x squared, which is up. You have a y equals negative x squared, which your graph is going to go down. You have an x equals y squared, which your graph will go sideways. And then you're going to have an x equals negative y squared, where your graph will go sideways, but that way. So you need to decide on here which graph you're going to get. So for this right here, it looks like we're going to have a y equals x squared. So that means I'm going to move these two x values to the other side. So negative 4y is equal to negative x squared minus 4x. So you notice I have my y equals x squared. And I do notice that all my variables are negative. So I'm going to divide by negative 1, and I'm going to get 4y squared equals x squared plus 4x. So that's what I have so far. I realize that I have an x squared and an x, which means I do need to complete the square. So noticing that this is a 1, I can complete the square, because if this was not a 1, I would have to factor that value out, but I don't because it's a 1. So I just need to take half of this term, so half of 4 is 2, square that value, which is 4. So I'm going to add that to both sides. And so now on the right side, I'm going to have x plus 2 times x plus 2 quantity squared. On the left side, I'm going to factor out a 4. And that's going to leave me, and I'm going to switch these around, it's going to leave me with y squared plus 1. Okay, why did that just happen? I shouldn't have a y squared here. So let me fix that. Okay, so yeah, let me fix that. All right, so I completed the square. I added 4 to this side. I factored out a 4, and I have y plus 1. So now I have a y equals x squared graph. Okay, so now this is my equation. My vertex is going to be negative 2, negative 1. Personally, I don't like to leave my graph like this. I like to leave it like this. Y plus 1 is equal to x plus 2 quantity squared. But see this 4? I'm going to divide by 4, and so that's going to make it 1/4. And the reason that I like to do that is because from this equation right here, this right here is my a value. And if you remember that my a value is equal to 1 over 4p, p being the distance from my vertex to my focus. And although this question did not ask me to find the focus point or the directrix, you will have to know that. And then just one other way I could write this is this, 1 over 4 times x plus 2 quantity squared minus 1. So just one other way I could write it. But basically, this is vertex form. My vertex is negative 2, negative 1, which is here. Because it's a y equals positive x squared graph, it is going up like this. And of course, if I wanted to find my focus point, I could. It would be up in here because your parabola is always cupping the focus point. The next question says, there we go, find the focus of the parabola. So this, I like to write the y values on the side. So I have negative 12y equals x squared. So if I divide by this negative 12, I get y equals negative 1 over 12 times x squared. And just a note that if I don't have to complete the square, then my center for this value is going to be just 0. My vertex is 0, 0. See how it's negative 112 times x minus 0? Okay. So my vertex being 0, 0, this is a y equals x squared graph. but it is negative. So that's telling me that my graph will go down like that. Your job is to find the focus. So the focus is going to be found by taking this part right here, okay, and setting that equal to 1 over 4p. So negative 1 over 12 is equal to 1 over 4p. I'm going to cross multiply, and I get negative 4p is equal to 12. P is equal, and I'm going to divide by negative 4, so P equals negative 3. So that means that if I drop down 3, that's negative, there's my focus point, okay? And my focus point is going to be 0, negative 3. At the same time, if I were to go up 3, and this would be y equals 3, I would have the equation for my directrix, because P, which is this distance here, is 3. That same distance from my vertex to my focus is the same as my focus to my vertex. The next question says, find the equation of the conic in standard form. So that basically means if it's a circle, I need to set it equal to r squared. If it's a hyperbola or an ellipse, it's going to be set equal to 1. And because I noticed the first two terms here, x squared plus y squared, and there's no value here other than 1 in the front, this is a circle. And also because they're both positive. So we're going to get x squared plus, I'm going to group these, 4x. And because I don't have to take out a number in front of the x squared, I'm going to complete the square because I have an x squared and an x. So half of 4 is 2. 2 squared is 4. Plus y squared, and then I have the minus 6y. Half of 6 is 3. 3 squared is 9. Equals negative 12, but don't forget that whatever you did to one side of the equation, you have to do to the other because it is an equation. So because I added 4 and added 9, I do have to do that here. All right. So on the left side, I have x plus 2 quantities squared, plus here we have y minus 3 times y minus 3. So y minus 3 quantities squared is equal to this. 9 plus 4 is 13, and negative 12 plus 13 is 1. So because this is a circle, and this is the equation of my circle in standard form, I know that the center of my circle is going to be negative 2 comma 3. I know that r squared equals 1, because this value right here is r squared. So if r squared equals 1, r is equal to the square root of 1, which is 1. So that means that if I go over 2 and up 3, there's my center, and I would just go 1 all the way around, and then there's my graph of my circle. For this problem right here, it's another solve the equation, but from 0 to 2 pi also, again, from 0 to 2 pi. This is just another way of writing that. So this one right here, we're going to start off with 2 sine squared of theta minus 3 sine of theta plus 1 equals 0. So for this equation, it's already set equal to 0. So we are going to factor because it is quadratic. And our restrictions go from 0 to 2 pi, so I don't have to limit them with my inverses. This will be 2 sine theta times sine theta is going to be 2 sine squared of theta. To get positive 1 here, but this is going to add up to be negative, they're both negative. And so this is negative 1 and negative 2 makes negative 3. I'm going to split both of these up. This says sine of theta minus 1 equals 0, so sine of theta equals 1. And then theta is going to equal arc sine of 1. So that's asking me where is sine 1. And this one is going to be 2 sine of theta minus 1 equals 0. So 2 sine of theta equals 1. Sine of theta equals 1/2. And theta equals arc sine of 1/2. And so now what we're going to do with this is I'm going to graph this again, and I want to know where is sine 1. So remember, sine starts at 0, goes up, comes down, and ends back at 0. Where is sine 1? So I'm looking for 1. Where is it 1? Well, it's 1 right here. So where am I? If this is 2 pi, this is pi over 2. So where is sine 1? From 0 to 2 pi, it's right there only at pi over 2. So far, so this is saying theta is equal to, so this is a little confusing because this is saying theta, meaning degrees, and this is saying put your answer in radian form. So I'm just going to keep it in radian form, so that means this, I'm going to make this an x. So this is going to be pi over 2, And then this one's asking me, where is sine all the way around from 0 to 2 pi? Where is it 1/2? Now remember, sine, all students take calculus. Sine is in the first quadrant, positive, here, and sine is in the second quadrant, positive, here. But here it's negative and here it's negative, so those two are out. So from here to here, sine being opposite over hypotenuse, and root 3 is here, this is a 30-degree angle. 30 goes into 186 times. That means it's a pi over 6. So here we are at pi over 6. And then from here to here, again, is 30-degree reference. But what that's telling me is from here to here is pi over 6, which means from here to here is 5 pi over 6, because you're 1/6 short from being at 1. So my second value for this is 5 pi over 6. So this one says, graph the conic and find the focal points. This right here, because it's negative and because I have two squared terms, it's a hyperbola. Okay, so this being a hyperbola, I need to get this value here as to be 1. So first I'm going to flip-flop these. So 4x squared plus y squared equals 4. I'm going to divide everything by 4, okay? And I'm going to get negative x squared over 1 plus y squared over 4 is equal to 1. Okay, so now I have my hyperbola. I didn't complete the square, so that means that my center is at 0, 0. So far my center is at 0, 0. In the x direction, I'm going to look underneath here, and I'm going to go the square root of that value. So the square root of 1 is 1. So in the x direction, going left and right, I'm going to go 1. So I'm just going to say that's 1, and that's negative 1. In the y direction, I'm going to go the square root of this value, the square root of 4, which is 2, plus or minus 2. So I'm going to go up to here and down to here. Now keep in mind, I know most people look at that and they go, okay, I have 4 points. I need to connect all the points, but that's only if you were to make it into an ellipse, which it's not an ellipse because of this negative sign. An ellipse would be the same equation, but both of these values would be positive. So what I am going to do is I am going to make this into a box. And I am then going to put in my asymptotes, and there are my asymptotes. Now, your parabolas on your hyperbola are going to stem off whatever axis is positive. So if you notice this is y is positive, that means that my hyperbolas are going to stem off of the y-axis. So from here, they're going to raise up like that, from here to here. And for y down here, you're going to go like this. Couple of things to note. This line right here that connects my two vertices, that like holds on to those, that axis right there is called the transverse axis. Okay, that transverse axis just connects the two hyperbolas. The other axis that really doesn't connect anything, but just is sort of like a minor axis, but it's not always a minor axis because it could be actually larger. We call this axis right here a conjugate axis. Okay, so that's my conjugate axis, the one that doesn't really connect the two hyperbolas. So let's see, what else do we know? We know this value from here to here is our A value because it's the positive one. We know this value going across is my B value, and my C value is actually the value that's going to connect, that goes from my center to my focal point. So I need to know where I am, because that's actually the question, is find the focal points. So we're going to use the formula that goes c squared equals a squared plus b squared. C is my foci. So we're going to go c squared is equal to a is positive, so 4 plus 1. So c is equal to plus or minus the square root of 5. And so therefore, this point right here, which is 0, negative root 5, and this point right here is 0, comma, positive root 5. And so those are my two focal points. This question says, find the equation of an ellipse. Okay, so that's telling me right off the bat that I'm going to have some value here with x plus some value here with y, and then this is going to equal 1. So from the very first sentence, when it said, find the equation of the ellipse, I already know this. I also know that my focal points are 3, 6, so I'm going to go over 3 and up 6. So here's one focal point at 3, 6, and then I've got 3, negative 8. so that's over here, another focal point at 3, -8. So this value here is -8. This value right here is 6. All right, so we know that halfway in between our focal points is our center. So if we know that between here and here is 8 plus 6, which is 14, half of 14 is 7. So I'm going to drop down 7. And this is going to put me right here at 3, -1. And that means that's my center. So this will be x minus 3, and this will be, because it's -1, this will be y plus 1. Now, and this value from here to here, remember, is my c value. Okay? Also remember, because it's an ellipse, my ellipse, the focal point are inside. You see how that I'm drawing that? My focal points are inside. They're also on my major axis. Okay, so we also know that our minor axis is 10. So going across this way and across this way, that's 5 and that's 5. So if I were to count 5 over going to the right, that's going to give me my 2 endpoints from there and there. So that means if the minor axis is 5, and if I'm going to the right 5 and to the left 5, and those are in the x direction, that means underneath here is 25. 5 to the right, 5 to the left. The ellipse equation for focal points is c squared equals a squared minus b squared. So we know the c squared value because from here all the way up to here is c. And so from here to here is 7. So that means that's 49. We don't know a squared because a is positive. And in an ellipse, a is always greater than b. And then so minus b squared, we know b is 25. So that's minus 25. So that means a squared is equal to 49 plus 25. And so that's 4, 5, 6, 74. So a squared is equal to 74. So there's the equation for my ellipse. This question says, find the equation of the hyperbola. So what that's telling me already is we have an x value squared here. We have a y value squared here. And then we have this equal to 1. And I don't know which one's positive yet. But I do know my vertices are at 3, 1, 2, 3, -8. So here's -8 again. And this is at 3, -2. Oh, so therefore, this distance, sorry, -2. So this distance from here to here is 6. From -2 to -8 is 6, which means that if I count down 1, 2, 3, that's the center. That's where my center is. So that being my center, where is that? That's going to be at 3, -2, and another 3, which is -5. So my center is at 3, -5. So that means that we have x minus 3 and y plus 5. Now, because these are my vertices, okay, my vertices are the values that hold my hyperbola. So that means that my hyperbola is going to do this and this, okay? So what that means is that, so that means in the y direction, I went up 3, 3 up, 3 down, which means in the y direction, that's going to be 9. And because I'm going in the y direction up and down for my vertices, y is positive and x is negative. So let's see here. Oh, we also know that the conjugate axis, that's the axis that doesn't hold anything, is 2, which means that I went 1 to the right and 1 to the left. So that means in the x direction, I went 1 to the left and 1 to the right. So therefore, that's my equation of my hyperbola in standard form. For this problem, this is another hyperbola because you see the squared and the minus, hyperbola. Complete the square to find the equation, find all of the components. We know this is a hyperbola. So let's see, we're going to group first term. I'm going to group the terms first. So we have 4x squared plus 8x. And then we have minus y squared minus 4y is equal to 4. Okay, so I do notice that I do need to complete the square 2 times because I have an x squared and an x, and I have a y squared and a y. So what that does is that tells me I need to complete the square twice. not only do I need to complete the square twice, I also need to factor out this 4 and also this negative sign, because you can't have a negative value there. So factoring out the 4, you're going to get x squared plus 2x. Now, half of 2 is 1. 1 squared is 1. And now I have to factor out the negative sign. So negative times the quantity y squared plus 4y. Half of 4 is 2. 2 squared is 4. Is equal to 4. Now remember what I said is whatever you added to one side, you have to add to the other. But because I temporarily factored out the 4, before I add it to the other side, I do have to multiply it back in. So that's going to be a plus 4. And then see this negative sign that I temporarily factored out? Put it back in now. And so minus 4. So what I have, 4 minus 4, those are going to go away. Simplifying the left side, we have 4 times the quantity x plus 1 quantity squared minus y plus 2 quantity squared is equal to 4. Now remember, to put this in standard form, this value here needs to be a 1, which means that everything is going to divide by 4. So we get x plus 1 quantity squared over 1 minus y plus 2 quantity squared over 4 is equal to 1. So now that's my equation of the hyperbola in standard form. It gives me a center at x, y. So negative 1, comma, negative 2. So let's draw that. Negative 1, negative 2. So that's this value down here. In the x direction, I'm going to go the square root of 1. So I'm going to go 1 to the right and 1 to the left. In the y direction, I'm going to go the square root of 4, which is up 2, down 2. So I'm going to make my box, because remember, it is easy to think that you want to connect the dots, but do not, because you only do that on an ellipse. So we're going to put in our, make our box and draw in our asymptotes. We are going to find the equation for the asymptotes as well. Now, finishing this, we know that because the x squared term is positive, that my hyperbola will go and follow the yellows. I almost said brick road, but follow the yellow asymptotes like this. Okay, we need to find our focal point, so we're going to go c squared equals a squared plus b squared. And remember, in an ellipse, this is minus. So c squared is equal to a being positive 1 plus 4, 5. So c equals plus or minus the square root of 5. If my center was at 0, 0, my foci would be at root 5, 0 and negative root 5, 0. But remember, you have an equation y equals plus or minus root 5x. Now keep in mind, my center has been moved. My center was moved to this, which is negative 1, 2. So that value right here becomes x plus 1, right? And then the negative 2 will be a positive 2. So let me move this over a little bit. Positive 2, and that equals. So this is the equations of my asymptotes. Let's see. We got to also, so those are my asymptote equations. Whoops, what did I do wrong? Nope, I just messed up. Hold on. Let me see. I mixed my foci up with my asymptotes. So again, my focal points are here and here. For my foci, from my center, which is at negative 1, 2, so this point right here is going to be, because they're on the x-axis, it'll be negative 1 plus or minus root 5, comma, negative 2. And this point right here is going to be negative 1 minus root 5, comma, 2. So this will be plus, that'll be minus. Okay, asymptotes still is like that. However, asymptotes are y over x. So the square root of 4 over the square root of 1. So that's going to be plus or minus 2 over 1, which is 2. So these are the equations of my asymptotes. These are the equations, the points for my focal points. Okay, I think I got everything other than just to remind you, this that connects these two, transverse axis, this conjugate axis. Find the vertex, focus, and directrix. Again, one squared term means it's a parabola. All right, so let's see. We have y equals 3x squared minus 18x plus 29. I do have to complete the square because I have an x squared term and an x. This 29 is going to go over there. So y minus 29 equals 3x squared minus 18x. We do have to factor out the 3, so we go y minus 29 equals 3 times the quantity, x squared minus 6x. Half of 6 is 3. 3 squared is 9. Remember, whatever you add to one side, you do have to add to the other. And if you notice, I'm adding 3 times 9, which is an add 27. So this becomes y minus 2 equals 3 times the quantity x minus 3, quantity squared. That's vertex form. If you notice that my vertex is now going to be positive 3 from here and positive 2. I also want to find my focus and directrix, so I'm going to go over 3 up 2. So there's my vertex. It's a y equals x squared graph, and it's a positive x squared graph, so that means my graph is going to go up like this. My focus, I'm going to be using this point. So that's my a value. From this equation, y minus k is a times the quantity x minus h, quantity squared. So my a value is 1 over 4p. Okay, that's another number for another way of writing a value. So I'm going to go 3 is equal to 1 over 4p. And I'm going to cross multiply. I get 12p equals 1. So p is equal to 1 over 12. So that means that my vertex being 3, 2, that means that if I go up 1/12, because that's my p-value, that distance from here to here is 1 over 12. So that means that this was my vertex here. This is my foci. This is my vertex. So that means this being my focus point is going to be 3, 2 plus 2, okay. 3, okay. It's not, oh, there we go. 3, 2 plus 1/12, so 2 and 1/12, and then this will be 3, or this down here, which is going to be my directrix, right? That goes right through the y-axis, will be y equals, and then that'll be 2 minus 1/12, so that'll be 11/12, okay? 1 and 11/12. Okay, and that's the equation for my directrix. This says write the equation of a parabola with this information. So we know that our vertex is -5, 1, and we know that our focus is 2, 1. Okay, so what that tells me right off the bat is that my vertex in my graph is going to look like this, because my vertex always cups my focus point. So if you notice my focus point here, so definitely not a y equals x squared, it's an x equals y squared graph. So I'm going to start off with that, x equals y squared. Because my center has been moved, remember that goes with x, that goes with y, it'll be x plus 5 equals a times quantity y minus 1 quantity squared. This is what we need to find. So we know that the distance from our vertex to our focus is our p-value. And our vertex to our p here is our directrix, right? But p-value, if this is -5 and this is 2, that distance is 7. So that means that my p distance is 7. So a, which is also 1 over 4p, right? If my p-value is 7, this will equal 1 over 4 times 7, which is 28. So therefore, that's my a value. So my equation is going to be x plus 5 equals 1 over 28 times the quantity y minus 1 quantity squared. And there's the equation of my parabola. Write the equation of a parabola again, knowing that you have a focus at 4, -1. So here's 4, -1. So 4, -1, and that's my focus. I like to put an F or a V there, depending on what it is I'm trying to, what it is. So it helps keep that in mind. A directrix is y equals -5. So that is a line that goes through the y-axis. So that's a line that goes through the y-axis at -5. So here's -5. This value here was at -1. Remember that the distance halfway, that your focus to your vertex, vertex to your directrix, your vertex is halfway in between your focus and your directrix. So if this from here to here is 4, if I drop down 2, there's my vertex. So my vertex, remember, parabola cups my focus, so it is a y equals x squared graph. So my center is over 4, and then I dropped it down 2 from -1. So it's going to be 4, -3. So that would be x here. So this will be y plus 3 is equal to a times the quantity x minus 4, quantity squared. And remember, my a value is 1 over 4p. P being the distance from my vertex to my focus, and that's 2. So therefore, my equation is y plus 3 equals 1 over, p is 2, that's 2. So 1 over 8 times the quantity x minus 4 squared. Now, just a note, this is vertex form, but vertex form can be written in a couple of different ways. I could also write it like this: y equals 1 over 8 times the quantity x minus 4, quantity squared minus 3. I also could write it like this, where I move the 8 over here. So it would be 8 times the quantity y plus 3 is equal to x minus 4, quantity squared. So just all of those are ways that you could write the equation for your vertex, or your parabola anyways. Okay, and that concludes the introductory part of the review. So the second video, so this is part 2, second video is going to be the actual final exam review packet that was passed out into class. I'm going to be going over all of those problems next. So thanks for watching the introduction to the review, and I hope that helped. And stay tuned for part 2, which is the final exam review packet, problem solved.